So for an improper integral such as this one, find the antiderivative of cosine. And we're going sine from 0 to infinity. Now recall that sine of 0 is just 0. But what in the world is the sine of infinity? Well, that does not have a definition. So this number is undefined. So one could argue that this integral is divergent. However, why don't we take a look at the picture of cosine of x? There's cosine, and I want the area of cosine from 0 to infinity. So we're looking at all these green pockets. Now, geometrically, we have all kinds of symmetry. For instance, this pocket is knocked out by this pocket. This one's knocked out by this one. And that pattern goes on for how long? It goes on for forever long. But notice that there's really no one to wipe out this pocket here. It seems as though this one survives. Now, as a point of interest, what is the coordinate of this x-intercept? It would actually be pi over 2. Because recall that a cosine wave goes from here and it runs like that and it stops all the way up here, where this is 2 pi and the halfway mark was 1 pi, and if this is 1 pi, this is half of pi. Now, why did I change the color? Well, since this piece was the only one that survived, I am interested in it. What would be the area of this yellow piece? Well, we know how to find areas. Set up an integral from 0 to pi over 2 of the graph cosine x, right? Because this is a cosine wave. Now do the algebra here, do the calculus there, that gives you 1. So goodness gracious, what's the answer? Is the original integral divergent, or does it equal 1? Well, that is a bit controversial. So there's my lame answer. I am torn between the two, because in one instance I can appreciate the geometry, but in the other instance I have to respect the algebra. So honestly, go flip a coin and see which one it lands on. Or, speak with your professor and see what he or she would prefer.